Hello. The next polymer we'll look at is called nylon. Nylon involves the condensation of two different subunits. One is a dicarboxylic acid chloride called adipoyl chloride, and this is much more reactive than a carboxylic acid or ester. The other reagent is this 1,6-hexane diamine, two primary amines, each on the terminal ends of a hexane unit. What happens then in the condensation reaction is that one of the amino groups on the 1,6-hexane diamine will react and displace the chloride, the chlorine atom, to make an amide bond. Here we're mimicking what happens in nature when living systems take amino acids and produce amide bonds. Then the unreacted end of the 1,6-hexane diamine can find another molecule of the adipoyl chloride, and so forth. It can continue on until you have a multi-strand chain, repeating subunits, and we call this nylon. All right, we'll pause the video. When we come back, we will make nylon. All right, everybody, here we are in the lab, in the hood, to perform the reaction, the making of the nylon. And what I have is I have a 50 ml beaker to perform the reaction in. I have both my reagents, the adipoyl chloride and the 1,6-hexane diamine. Now one of these is in water, the diamine is in water, and the adipoyl chloride is in hexane. You know those two don't mix. So what we're going to do is we'll put them together, and at the interface between the two phases will be the nylon being produced. Once that's produced, I will pull that out using a copper hook. The copper hook is right here, okay? Now, when I do this, I'll need to add some external base because there'll be a lot of HCl given off, and we don't want to neutralize the primary amines. So this will be a strong base that will neutralize the HCl given off. Part of your questions post-lab is what bonds are being broken and what bonds are being formed. So look at it carefully so you account for all the bonds broken and all the bonds formed. Okay? Now when you go to pull this nylon out of the beaker when it's being formed, you could actually pull long strands. And we have a little competition normally where you do that. But today we'll just pull out a moderate length strand and we'll dry it on this piece of nylon. We'll pause this piece of paper towel. We'll pause the video, and when it comes back, the nylon will be dry, and we'll test the properties of it. Okay? So here we go. First thing is, I will pour in my 10 mils of the hexene diamine into the reaction vessel, the 50 ml beaker. Okay. Next, I will add, I think it says 10 drops of sodium hydroxide, 6 molars, pretty concentrated. 10 drops, half a mil. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's in excess, that's good. And then I will carefully pour down the sides of this reaction vessel the adipoyl chloride, and we should begin to see right away the formation of the nylon strands. I don't want to mix this up too much. I want to just pour this carefully in here. And again, I have it in the fume hood because it's quite odoriferous, and I really don't want to be smelling these reagents. Okay, so hopefully you can see there's two layers, a bottom layer and a top layer, and slowly the nylon will start to form between the two if everything goes well. And when it starts to form, then I'll pull it out with these strands. I'm hoping you can see that there's a beginning of formation of some strands. See the strands here forming? All right, so as those form, I will let them form a little longer, and when I get enough of them, I will begin to pull the nylon out and then place it on the paper towel. All right, the nylon has started to form well, and what happens is the nylon actually forms an interface that prevents the two reagents and the two layers from finding each other. So as I pull it out, I'll make more and more nylon. And hopefully you can see that this will be a slow process. Watch this. Oh, look at that. The strand broke. That's not useful. But that's because I don't have as much skill as some people, I guess. Or maybe I'm a little too hasty. So I'm going to pull this nylon out carefully and slowly. Looks like it's one that breaks again. So I obviously wouldn't win the prize for the longest strand, but maybe it'll get better over time. Let's see. Now I'm just pulling out pieces of nylon. That's a longer strand. Look. Oh my. Look at that long strand coming off. Finally, I got a long strand. I'm going to stop this after about a foot or two. But again, if you do this well, you can actually pull this out for many, many feet and yards. All right, I'm going to pause the video. I'm going to put the strand down. I'm going to let it dry. And when we come back, we'll look at its properties. Okay, everybody, it's been about 10 minutes. Now, this nylon has been drying, and I notice as it dries, it gets more able to withstand pressure. So this is a strand, portion of a strand. And I'm going to give it a little pull, and you can see, hopefully, it's starting to stretch, right? Let's get this focused on this nylon string. And it's beginning to stretch, right? So you can see, hopefully, grab this end. It's hard to do in this camera. It's like trying to cut your hair in the mirror, right? Okay, so if I hold the strand and focus the camera on this strand, you can see it's beginning to stretch, right? And as it gets drier and drier, it's able to stretch more and more. One of your questions is, it's useful in clothing. So you have to relate this property of nylon, the stretchability, right? As it gets more and more dry, it's able to stretch more and more without breaking. At first it broke easily, right? But now it's getting really dry. It's really stretchable. I'm putting it out further and further and further, okay? So I think that's going to be all you'll need for this lab. One more video will be the polymer disc and the radon, which Dr. Lawton will post for you. Okay, take care, guys. See you later.